Moving on to our next speaker, we will be hearing from Richard England of Southern Methodist University. So whenever we're ready.
Hello, my name is Richard England, and I work in the Office of Information Technology at Southern Methodist University, where my primary role is that of HPC System Administrator, one of two of us who keep the wheels turning on the Mainframe 2 supercomputing cluster. Shortly after I started at SMU in 2017, I was assigned a new project to deploy a software framework that had been requested by an incoming professor from the University of Illinois at Urbana-Champaign, Professor Barbara Minsker, who I believe will also be speaking to us today. That framework, of course, was Clowder, and after meeting with Dr. Minsker's team to gather requirements, I requested some resources, started reading how-to documentation, and installing and configuring the various software components, most of which were unfamiliar to me at the time. After a few months, and after several email exchanges with Rob Cooper and Luigi Marini, all those pieces came together and at least mostly did what they were supposed to. That first deployment exists entirely in our VMware vSphere environment on 4 VMs that host only 1 or 2 services each, one for MongoDB, another for Elasticsearch and RabbitMQ, another for Docker and all the extractors, and another for GeoServer and Clowder itself. Lacking familiarity with the services and wanting to protect the rest of our network from any possible security threats, I placed it in a subnet mostly isolated from the rest of our campus network. I customized the file system and directory structure, bearing in mind that we might eventually need to extend some of those that host data and log information. But within a short time, I found myself wishing that some decisions I'd made during the initial deployment had been different. I had requested some large file systems that I came to realize would probably never see more than 5 to 10% usage, whereas I had not requested enough capacity for some others that were going to grow much more quickly. For some of the VMs, I had not requested enough processing power or memory, and above the vSphere framework itself, there was no redundancy. Each service had one and only one host. Also, since we were using the manual installation with the larger components being installed as packages rather than as containers, the architecture was neither efficient nor very scalable. The update process was a bit burdensome in that we discovered that each update carried a risk that some extractors would quit working and would need updates as well. Nevertheless, based on user feedback, the framework was working well. In time, faculty in other departments began to express an interest in perhaps using Clowder for their own projects. And there was also an interest in eventually being able to avail the service to collaborators outside SMU. However, these things require more scalability and dependability than I'd built into that first deployment. Hence, last year, we began an effort to design a new architecture more capable of serving not only the civil engineering department, but the SMU campus as a whole. For our new deployment, we transitioned to a more containerized architecture. Though most production deployments are installed using the manual installation process, we believe that containerizing most of the framework should allow for more efficient use of system resources, increased scalability of our environment, and easier and faster updates to the framework. Our Linux support team had recently deployed a Docker swarm that so far was only being used for experimentation and learning, and the new Clowder framework presented a good production use case for that swarm. Within the swarm, we can easily tweak resource allocations to individual containers without having to request additional resources from our VMware team, which has been very helpful since we did need to make some such adjustments based on results of preliminary tests. Because of limitations to storage access in our Docker swarm, we did not abandon the use of VMs entirely. Our GeoServer, Elasticsearch, and MongoDB clusters now run as replicated services, but on VMs in the vSphere environment out of concerns regarding the use of NFS for hosting their data, though we may be able to migrate these to the swarm sometime in the future. We also continue to run our web front end on a load-balanced pair of VMs as opposed to using a Traefik container. We did this largely to accommodate internal security requirements regarding public-facing web services. I'm simply much more familiar and confident in my ability to manage the Apache web server in compliance with those requirements. Other than the load-balanced VIP serving the web front end, the back-end components reside on our internal network, protected by firewalls, offering a good deal more security than what exists for our legacy instance. For our first use case, we have uploaded data related to an event called Think, Play, Hack, a conference SMU hosted on our campus in Taos in July 2019. The full collection consists of about 1.5 terabytes of files from a variety of sources such as folktales and internet forum archives. The datasets range from 6 megabytes to over 600 gigabytes of mostly CSV files and ASCII text. Clowder provides a means to store and present data for other such events and could provide a platform for rudimentary cleaning and structuring of data using extractors to ease the workload of those preparing data for the events. The next phase of the project will involve migration of data sets from our legacy Clowder instance to the new framework. These were uploaded by Professor Mensker's research team in the Civil Engineering Department for use in studying infrastructure needs for the city of Dallas. They range from several gigabytes to 3.5 terabytes of geospatial files and images. Clowder offers a means of storing and sharing data to allow for continuity between students and projects. Dr. Mensker envisions a workflow of extractors to power a service and dashboard to expand her research to other cities. I expect the migration of this data to be one of the more challenging tasks in this project due to a few regrettable customizations I made during our initial deployment. But once we complete this task, our plan is then to open the new campus Clowder to Dr. Mensker's team to begin using it. We have a couple of other use cases in scope as well. One professor in our earth science department has over the course of her career collected and studied leaf fossils. As she nears retirement, she's looking to Clowder as one of several possible archival options for users to view, categorize, and interact with about 50 gigabytes of fossil images and associated metadata in Excel spreadsheets. Clowder offers possibilities for automated metadata extraction and image processing, as well as structuring and storing the fossil images in her collection. Another professor in our chemistry department has a library of chemical reactions she and her students have been studying, about 50 gigabytes of data comprised of about 50,000 files of images and code. Currently, her database only stores the final products and is not itself a part of the workflow that generates them. She's looking at the possibility of using Clowder to not only store results, but also to host the workflow and to generate plots and figures and run various quantum chemistry tools and applications by way of custom extractors. We still have much to do in building out the SMU campus Clowder, as we have only just completed the first round of preliminary testing, but we are well on our way to offering a more robust and reliable Clowder framework to our faculty and their research teams. I would like to acknowledge and thank a few folks at SMU and at NCSA who have contributed time, effort, and moral support toward making this project a success. Neither of our Clowder deployments would be working today if it weren't for their assistance. Thank you for listening.
Thank you again, Richard, for that great in-depth presentation about your work over time with using Clowder and all of the possibilities there.
Richard, Luigi Marini asks, would you be willing to share some of your notes on your setup with the community?
Yes, probably so, once I get them in a presentable format. My notes right now are pretty sketchy, but I'll try and do that and get something out there so that others can share.
Thank you, Richard. That is something that you could share certainly via the Clowder Slack or get in touch with us, and we can see once they're in a format that is shareable, spreading that a little bit. But very impressive presentation.
Well, thank you.
I do see a hand raised from Deep Chatterjee. Deep, do you want to ask your question?
Yes, thank you, Richard. I was wondering regarding your quantum chemistry simulations that you talked about, how expensive are they and how easy it is to connect a framework like Clowder to an HPC environment and then put the results back into Clowder?
Well, I'll be honest, I don't know a lot of detail about these specific projects that are being done within Clowder. I'm more of an infrastructure person. That is one of the use cases that was identified as we were discussing the path forward and planning the project. It has not been implemented yet. But even once it is, I suspect that my understanding of what they'll be doing within Clowder will be a little bit surfacey. Even with Dr. Mensker's project with the infrastructure for the city of Dallas, I know where the data is. I know essentially what that data is made of. I don't really know what it is exactly that they're doing with it in terms of which applications they're using, what type of, what the details are and what they're doing with it. However, I believe Dr. Munster will be sharing next, I think, and she may go into some more detail on that project. But the chemistry project is something probably a few months out.